Okay, so for example 3, I chose to do this equation. So it says that we need to sketch the graph, identify domain and range, all asymptotes, removable discontinuity, and if there is a y-intercept. So first what we're going to do is find the vertical asymptote. So what you want to do for that is you want to set this bottom equation equal to 0, and you're basically going to just so we're going to have x minus 2 and x plus 3, because you can multiply -2 and -3 to get -6, but when you add -2 and -3 you get +1. So that is going to be our vertical asymptote. So x equals 2 and x equals -3. So I'm going to go to my graph and I am going to do my dotted line over the 2 and over the -3. So now what this is telling us is that our graph will not go outside of these dotted lines. So the next step is finding the horizontal asymptote. So you're going to basically compare the degrees of the x in the top and the numerator and the denominator. So we have x to the first power and x to the second power. So if the numerator degree is less than the denominator degree, then y will always equal 0. So I'm going to take a different colored pen and I'm going to put my dashed line on y equals 0 because it's a horizontal asymptote. So to find your y-intercept, you're going to rewrite your equation, but you're going to plug in 0 for everything. So 0 minus 2, -2 over -6, those cancel, and this equals 1/3. So our y-intercept is just going to be right here. So y-intercept equals. Okay, so here I wrote down our vertical asymptote, which is x equals 2, x equals -3, our horizontal asymptote, which is y equals 0, and then our y-intercept, which is 1/3. Okay, so now we're going to graph it. So over here, I'm going to make a table and I'm going to plug in numbers for x. So I'm going to do +1, so we'll do 1 minus 2 over 1 squared plus 1 minus 6. So I'm just going to take my calculator and do 1 divided by -4. So that's -0.25. And then we'll do -1. So we have -3 divided by -6, which is 0.5. So for 1, we have, I'll just put it right here, -0.25. And for -1, we have 0.5. So now let's do some on the outside. So let's do -4. So we'll do -4 minus 2 over -4 squared plus -4 minus 6. So negative 4 minus 2 is negative 6 divided by negative 4 squared is just 16. 16 minus 4, so that's 12, minus 6 is just 6. So negative 6 divided by 6 is just negative 1. Okay. Since we have a point over here, we're also just going to graph negative 5. So we're going to do negative 5 minus 2 all over negative 5 squared plus negative 5 minus 6. Because we need to know whether it's slightly above this point or slightly below. That way we know which way our graph is going. So negative 5 minus 2 is negative 7. 5 squared is just 25. Minus 5 is 20. Minus 6 is 14. So that gives us negative 1/2 or negative 0.5. So at negative 5, we have negative 0.5. So it's slightly above that dot. So now we're able to have our formation. Okay, so we are going to connect the dots on this graph. So this graph is going like this. Since we have enough points on this graph, we can say that this graph is going like this. And so now we need to do 2 points on this side so we can figure out which way this is going. So let's do 3 minus 2 over 3 squared plus 3 minus 6. So we have 1 divided by 9 plus 3 is 11. Okay, so we have our 1/5 right here. So now we are going to do, let's do 4. So we have 4 minus 2 over 4 squared plus 4 minus 6. So we have 4 minus 2 is 2 divided by 16 plus 4 is 20 minus 6 is 14. That's 1/7. So we're even getting closer to the line. So as we get closer to the line, we can mark that it's going to be like this. Okay, so now we're going to state the domain and range of the graph. So the domain is all the x values. So here this is pointing to negative infinity. Here this is pointing to positive infinity. So you're gonna have negative infinity into positive infinity, and you can't have brackets because those numbers go on forever. And the range, you have this arrow pointing up to infinity, this arrow pointing down to infinity, always right from least to greatest. So 0 or negative infinity into positive infinity. So here's what we started out with. These were our vertical asymptotes, which are the green lines. We figured that if the degree in the numerator is less than the degree in the denominator, then that means that our horizontal asymptote will always be y equals 0. So we have the dashed blue line marked here. We found our y-intercept by plugging in 0 to each of our x values, which gave us 1/3. So there we were able to plug in our y-asymptote right here. This line went like this after plugging in a few points. This line went like this after plugging in 2 points. It's kind of hard to see this one. And then this line went like this after plugging in 2 points.